Okay, we're back with Math 196, and we're still going through the appendices, and we will start this lecture, this videotape thing, as factoring, with a little exclamation part, because it's fun. It's a little puzzle, trying to figure out how to factor. And from the distribution lecture, we had this example. So, the example from distributions was that we found x plus 3 times x minus 5. We can distribute, and that would give us x squared minus 2x minus 15. So we can go this way, right? If you have two things, you multiply them together, distribute, and you get the result. Factoring is the other way. If we start with x squared minus 2x minus 15, how can we break that apart into two pieces? How can we find those two pieces? So factoring is sort of the opposite of distribution, or is it undoing distribution? Distribution is undoing factoring. The mathematical term is inverses. They're inverse operations. So, 3 topics in this mini lecture here. First is common factors. Second is quadratics. And then the third is just some notes about, when the procedures don't work and things to keep in mind. Okay, so common factors. We'll draw a little horizontal line. Usually the easiest thing, suppose we have an example. We want to factor x to the 5th plus x to the 4th plus x cubed. What's that? Well, what's common to each of these 3 terms is an x cubed, right? X to the 5th is x squared times x cubed. X to the 4th is x to the 1st times x cubed, and x cubed itself is 1 times x cubed. The 1 is actually pretty important there. So we've got an x cubed in each, so we can just say, well, we'll factor that out. Take the x cubed out, open a big parentheses, and everything that's left behind goes in the parentheses. So this x squared plus the x to the 1st, and an x to the 1st is just an x, and then the plus 1. And I guess I don't need this parentheses way out there. So there we go. We've factored out the common factor. So anything that's the same, the x cubed comes out, and you just put whatever's left behind inside the parentheses. Note that if you factor everything out of something, right, this x cubed, when we factor out the x cubed, what's left behind is a 1. And you can check, anytime you do a factoring, you can check by distribution, because they're sort of opposite things. If I factored out the x cubed to get this, well, if I distribute, I should get back to where I started. That's here. So x cubed times x cubed times x squared plus x plus 1. You distribute the x cubed. What do you get? X cubed times x squared. Well, 3 plus 2 is 5. X cubed times x, well, you have 3 x's and you multiply by 1 more x, that gives you an x to the 4th. And x cubed times 1, well, anything times 1 is itself, so we get an x cubed. That's what we wanted, right? So factoring, distribution, they're opposite things. Anytime you factor, you can always check by doing distribution. So a second example of common factors, a little bit more complicated, is 6x squared y cubed plus 4xy to the 4th plus 8y to the 5th equals what? Well, what's the common term here? 2, because 6 is 2 times 3, 4 is 2 times 2, 8 is 2 times 4. We have an x squared, an x, and no x here, so we can't factor out any x's because x isn't common. Y cubed, y4, y5. So there's 3y's here, 4y's here, 5y's here. We can take out a y cubed. That's our common term. So 6x squared y cubed plus 4xy to the fourth plus 8y to the fifth. If we take out our common term, that's the 2y cubed. What do we have left? Well, taking 2 out of 6 leaves a 3. We leave the x squared alone. Taking all of the y cubed out leaves a 1. So this is technically times 1, but we don't need to write the 1 there. 2y cubed, if we take that out of 4xy to the fourth, taking a 2 out of a 4 leaves a 2. X we leave alone. Y to the fourth, if we take out 3 of those y's, we're left with 1y behind. 8y to the fifth, if we take out 2y cubed, what are we left with? Well, if you take 2 out of 8, you're left with a 4. If you take 3 of the 5y's out, you're left with a y squared. And there we factored it out. Note that these terms in the parentheses do not have anything in common. I guess these 3 terms. There's nothing that can be factored out of there. And again, if we wanted to check, you can just distribute the 2y cubed to each of these things and see what you get. So common factors are important, and it's very useful to actually, before you do any other kind of factorization, to factor out the common factor first and see if that simplifies your life a little bit. Okay, quadratics. In quadratics, factoring quadratics is mostly practice. So we'll start with this. X squared minus 2x minus 15 equals what? Well, it should be parentheses, right? And x plus something in here, x plus something in there. But how does distribution work? So to be able to figure out what goes here and here, we need to think about distribution a little bit. So distribution, if I take x plus something, we'll just call it a, times x plus something else, we'll call it b, and we distribute, what do we get? We got 4 terms, right? That's what we saw when we did distribution. X times b, that gives me an x squared plus a b times x. A times x plus a times b gives me an ax plus ab. So we get x squared plus a plus b x plus ab. And note what happened here is that when we do distribution, you get 4 terms, but 2 of them combine to give me the middle term. Okay, so what do I need to factor x squared minus 2x minus 15? Well, the minus 15 is 2 numbers. You lose the hashtag symbol for stands for numbers originally, and then Twitter stole it to use it as a hashtag thingy. So 2 numbers that multiplied together that's the AB part. And the middle term, the minus 2, it's the same 2 numbers added together. That's the a plus b. So what we need to do is find 2 numbers. When you multiply them together, you get minus 15. You add them together, you get minus 2. Note that if you multiply 2 numbers together and get a negative, one has to be positive, one negative. So one positive, one negative. If you add a positive number and a negative number together and you get a negative number, that means that the negative number had to be bigger. And of these 2 numbers, minus is bigger. So minus 15 is what? Well, it's minus 15 times 1, and we know that the negative number has to be bigger. Or it's minus 5 times 3. Those are really the only options. Minus 15 plus 1 is minus 14. Minus 5 plus 3, that's minus 2. So this is what we want. Right? 2 numbers multiplied together gave me minus 15, so minus 5 times 3 is minus 15. Two numbers added together gave me minus 2, minus 5 plus 3 is minus 2. So what do we get? X squared minus 2x minus 15 should be equal to x minus 5 times x plus 3. Yay, so that should work well, but let us check by distribution. And so x minus 5 times x plus 3 is, distribute the x's, x squared plus 3x, and then we distribute the minus 5, and we get a minus 5x minus 15. And if we add that together, what do we get? X squared minus 2x minus 15. Note that these two terms here combine to give me the minus 2x, which is the middle term in the original quadratic. And so we've successfully factored that one. Okay, so another example. Example 2, x squared plus 5x plus 6. What do we need to do? Two numbers that multiply to give 6 and add to give 5. And what do we know about these numbers before going in? Both plus or both minus, right? If you multiply plus times plus, you get plus, minus times minus gives plus, but if you had plus times minus, you end up with a negative number, and this 6 is positive. Add two positives, you get a positive, but if you add two negatives, you get a negative. So our two numbers must be positive, positive, because if we add two positives, we'll get a positive. If we added two negatives, we'd get a negative, and we've got a positive 5 here. So we just break down 6. 6 is 6 times 1, or 6 is 3 times 2. That's really the only kind of multiplications that will give you 6. 6 plus 1, these two numbers here, that gives us a 7 when you add them, so that's not useful. 3 times 2, well, 3 plus 2 is 5, and that's what we want. Boom. So x squared plus 5x plus 6 is x plus 3 times x plus 2. Not too bad. Okay, so that's sort of the basic quadratics. There's something that the book calls the AC method. Right? What we did above works as long as the coefficient of the x squared, the number multiplying by the x squared, that's a 1. If it's not a 1, how do you handle that? Okay, well, in fact, you handle it exactly the same way. So 2x squared plus 11x plus 12. Well, the beginning of the method is the same. Here what we want is two numbers that multiply together to give 2 times 12 and add to give 11. So need two numbers multiply to give 24, which is 2 times 12, add to give 11. Great, so what do we need to do? We need to break down 24. 24 is, before we do that, 24 is positive, so either positive and positive or negative and negative. Right? Multiply two positives together, you get a positive. Multiply two negatives together, you get a positive. Since the 11 is positive, that means they must both be positive. So 24 is 24 times 1. It's 12 times 2. It's 8 times 3. It's 6 times 4. And I think that's it. So which of these pairs of numbers add to give you 11? So 8 and 3 are the numbers that we're looking for. So how do we handle this now, because we need to deal with this 2 out front, and so we can't just say, well, x plus 8 times x plus 3. So remember that when we, if we go slide back a little bit, the middle term, the minus 2x here, is the sum of 2 other terms that you get from distribution. So what can we do with the 11 is this middle term is actually an 8x plus a 3x. So we'll take our original thing, 2x squared plus 11x plus 12, and we'll break up that 11x into a 2x squared plus 8x plus 3x plus 12. And there's the 4 terms that you get from distribution. Now what can we do with this? Why is this helpful? Well, looking at these 2 terms, I can take out a common factor. That's the 2 can come out of an 2 and an 8, and an x can come out of an x squared and x. So we get a 2x. What's left behind if we take 2x out of 2x squared? Well, the 2's come out, and one of the x's, we're left with 1x. When we take a 2x out of 8x, you're left with a 4, and then the x is gone, so does x plus 4. Out of these 2, well, the x can't come out, but we can take out a 3. If you take a 3 out of a 3x, you're left with an x. If you take a 3 out of a 12, you're left with a 4. And now, something very nice has happened. We've gotten one of the 2 terms that we need in x plus 4. So, x plus 4 is common to both of these. If we take that out, what do we have left? Well, we take out the x plus 4. What's left behind from this term is the 2x, and what's left behind from this term is the plus 3. And so there we factored it out. And the check is by distribution, x plus 4 times 2x plus 3. What's that going to be? Well, x times 2x is a 2x squared. Excellent, that's what we want. Plus x times 3 is a 3x. 4 times 2x, that gives me an 8x. 4 times 3, that gives me a 12. No, we got all 4 terms here by breaking up the 11x into an 8 and 3. So if we add up everything, we see that it works. So the problem then is this middle term, we need to be able to break it up into 2 things. So let's see what example I'm at now. Example 4. Example 4. God, my x's are just really sloppy today. Example 4. 15x squared. So we want to factor this, minus 17x minus 4. And again, we want 2 numbers. Multiply to give me minus 60. And why minus 60? That's 15 times minus 4. You multiply the first number by the last number. And it's called the AC method because this is usually called A, this is usually called C. A times C, 15 times minus 4, that's minus 60. And they add to give the middle term. Oh, something goofy happened there. Minus 17. So what do we know here? 1 positive, 1 negative, because it's a negative 60. And the negative is bigger because when I add a positive and a negative and I get a negative 17, well, that means that the negative number must have been bigger. So minus 60 has a lot of ways to break it up. It's minus 60 times 1, minus 30 times 2, minus 20 times 3, etc., etc. But the minus 20 times 3 is the term that we're actually interested in because minus 20 plus 3 is minus 17. Great. So let us break up our minus 17x here into a minus 20 plus 3. So 15x squared minus 17x minus 4. We'll break up the minus 17x into a minus 20x plus a 3x minus 4. And we look to factor. out common terms from the first two and the last two. Nothing factors here, which makes us sad. So I got these two in the wrong order. Let's try this one instead. Well, out of these first two terms, we can factor out a 3. Comes out of both a 3 and a 15, and 1x. So a 3x, and left behind is a 5x plus 1. And remember, if you factor everything out, you're left with a 1. Out of these two, well, 4 can come out of a minus 4, in fact, can come out of a minus 4 and out of minus 20, and we'll be left with a 5x here. Remember, if we factor out the minus sign, we're left with a positive 5x. And then if we take everything out of the minus 4, we're left with a 1. And note again, we have a common factor, which we love. So we factor out the 5x plus 1. What's left behind goes into a parentheses. That's this 3x. Ooh, moved my screen a little bit. A 3x and a minus 4. And you can check by distribution, but I won't, because this video is probably getting long enough as it is. Okay, so common factors, quadratics, the AC method, they're pretty straightforward. You just have to practice them, really, right? The more you do it, the easier it is. Remember that whenever possible, you can pull out the common factors. Part 3, a note to keep in mind. AC method doesn't always work. Period. Well, exclamation point, because that's kind of important. It doesn't always work. It works it works often, but it doesn't always work. So, for example, x squared plus 7x plus 11 equals what, if you want to factor it? Well, we need two numbers, multiply to give 11, add to give 7, but the only possible numbers that multiply to give 11 are 11 and 1, and that adds to give 12. Again, doesn't work. Sad. But, as we'll see later, the quadratic formula will come to our rescue, and we get this kind of complicated looking formula, which you can verify by distribution again, that x squared plus 7x plus 11 does in fact factor into something involving square roots. A big theorem says that every quadratic does factor, but you have to use complex numbers, which we're really not going to go into in this class. So, you know, the AC method will work a lot of the times. Quadratic formula will work all the time. But the quadratic formula is much more complicated, so it's much easier sometimes and faster, which is important when you're doing tests or quizzes or something, to use the AC method. And one last thing, or example 2 of the notes, what about x squared minus 5? Well, if we tried the AC method, we can actually write this as x squared plus 0x minus 5. So if the term is missing there, right, there's no middle term, right, that really means it's times 0, because 0 times anything is 0. So x squared minus 5 we can write as x squared plus 0x minus 5. And what does that mean? Two numbers multiply to give minus 5, add to give 0, one positive, one negative, because they multiply together to give a negative. And here, if you add two numbers and you get 0, what does that mean? They have to be equal and opposite. But multiplying to give minus 5, that's only minus 5 times 1. And again, we're sad because that doesn't work. But we look at x squared minus 5, and we think, note, a squared minus b squared, right? A difference of squares, that's a minus b times a plus b. And 5 secretly is a perfect square. In fact, every number, every positive number, is a perfect square because it's square root of 5 squared. So, what does that tell us? X squared minus 5 equals x squared minus square root of 5 squared. And that's something squared minus something squared. So that does factor. X minus square root of 5, x plus square root of 5. Okay. So the AC method works, but as we can see from these two examples, things involving square roots, it doesn't work quite so well for, and you need the quadratic formula. Difference of squares, a squared minus b squared. Well, positive numbers are the square of the square root, so you can actually use this very useful formula to factor something like that. Okay, and I think that finishes up everything to say about factorization, and then I think the next one will be on